Welcome to MRL. In this learning session, we'll be learning about mensuration. Mensuration is a very important branch of mathematics which deals with the measurement of plane figures and solid figures. Now, what is plane mensuration? Plane mensuration deals with the measurements of plane figures. The plane figures are one-dimensional or two-dimensional geometrical figures. They lie on a plane and are therefore called as plane figures. Now, in plane figures, we can measure their lengths, perimeter and areas in plane mensuration. In solid mensuration, we deal with the measurement of solid figures. Solid figures are three-dimensional geometrical figures. They occupy space and also have capacity. And in solid mensuration, we measure the dimensions of the solid figures, their areas, volumes and capacity. Please remember that. Now, what are the plane figures? The plane figures, as I have already told you, they are the figures that lie on a plane. They are two-dimensional figures. They have areas. Their dimensions can be measured. Their perimeter and areas can be measured. Please remember that. Now, the important plane figures are rectangle, square, triangle, quadrilateral, parallelogram, rhombus, trapezium, circle, semicircle, polygons, annulus or a ring, rectangular path, rectangular cross path and combination of plane figures. So these are various plane figures. Now let us start understanding the important terms here. Now, what is perimeter? The perimeter is the boundary of a plane figure, and the perimeter also means the measurement of the boundary of the closed plane figure. Now, perimeter generally includes the measurement of the lengths of the sides of the plane figure, and taking a sum of that will give us the perimeter. And the perimeter is always, remember, is denoted by P. And when we measure the perimeter, the sides can be line segments or even curved lines. Now, region of a plane figure. The portion of the plane within the boundary, the portion of the plane within the boundary of a plane figure is called region of the plane figure. Now, let us try to understand with the help of the figures here. Now, if you see here, the circumference of the circle is the boundary or the perimeter of the circle, and the portion of the plane here is within the boundary, and that is what is called as circular region. Now, if you take the polygon has the line segment which form the boundary, and within the boundary there is a portion of a plane, and that is called as polygonal region. In a rectangular region, we have the boundary of the rectangle, and the portion of the plane within the boundary of the rectangle is called as rectangular region. And in a triangle, we have the boundary of the triangle, that is called as the perimeter of the triangle, and within the perimeter we have a portion of a plane, and that is called as triangular region. So please remember that. Now, area of a plane figure. The measure of the region of a plane figure, which also includes the boundary, is called as the area of the plane figure. Now, if you have to measure the area of the triangle, I have to measure the triangular region including the perimeter of the triangle, including the boundary of the triangle. So also, if I have to measure the the area of the rectangle, then I have to measure the rectangular region including the boundary of the rectangle, and so on. So please remember that. The units of measurements, we have to know this, very important it is. The measurement of length is always in centimeters or meters or kilometers. The area is measured in centimeter square, meter square or kilometer square, and generally the standard unit taken is meters and meter square. Remember that. The important chart here is of units of length. Now, you know the smallest unit in metric system is millimeter. So 10 millimeters make 1 centimeter, 10 centimeters make 1 decimeter, 10 decimeter make 1 meter, 10 meters make 1 decameter, 10 decameter make 1 hectometer, 10 hectometer make 1 kilometer. So this chart is very useful for us to calculate the various dimensions, areas and capacity, or what you call volume of any given plane figure or solid figure. Now, 1000 meters is 1 kilometer, very important relation. 1000 meters is 1 kilometer, 1000 millimeters is 1 meter, and 100 centimeters is 1 meter. Very useful for conversion. So please remember the full form of all these abbreviations, and also the important multiplication of each of these dimensions into higher dimensions, or higher dimensions to lower dimensions. Remember that, units. Units of area. The units of area are centimeter square, decimeter square, meter square. And you see here 10 millimeters into 10 millimeters becomes 100 millimeter square or 1 centimeter square. 10 centimeter into 10 centimeter becomes 100 centimeter square or 1 decimeter square. 10 decimeter into 10 decimeter becomes 100 decimeter square or 1 meter square. 100 centimeter into 100 centimeter is what you call 10,000 centimeter square or 1 meter square. 100 meters into 100 meters is 10,000 meter square or 1 hectare or 1 hectare. So when we want to convert the meter into centimeter, then multiply by 100 into 100. When we want to convert the hectare into meters, multiply by 100 into 100. So these conversions are to be very clear and very important for our calculations. Remember that. Now coming to the important study as to how to find the perimeter and area of plane figures. So let us begin with the first plane figure, that is a rectangle. We already know the properties of rectangle. A rectangle has 4 sides, that is AB, BC, CD and DA are the sides of a rectangle, and we all know that the opposite sides of a rectangle are equal. Therefore AB is equal to DC and BC is equal to AD. Now to find the perimeter of this, we have to add AB, BC, CD and AD as I have shown here. Now AB is L, add B, that is BC, add L, CD, again add B, that is DA. So L plus L becomes 2L, B plus B becomes 2B. So 2 times L plus B is the perimeter of the rectangle. Now if you want to find the area of the rectangle, then we have to multiply AB into BC, and that is equal to L into B. Therefore we have the perimeter of rectangle as 2 times L plus B, and the area is L into B. That is about the rectangle. Now if you want to find the perimeter of the square, in a square all the sides are equal. If you take the side of the perimeter square as L, then the perimeter is equal to AB plus BC plus CD plus DA, which is equal to 4L. And if you want to find the area of the square, then it is AB into BC, that is L into L, that is the L square. So the perimeter of a square is 4L and the area is equal to L square. So please remember that. Now coming to the triangle, a triangle has, as you know, has got 3 sides, and when I drop a perpendicular from a vertex to its opposite side, that is AB is perpendicular to BC. Now to find the area of a triangle, let us understand how to find the perimeter first. Perimeter is the sum of the side, that is AB plus BC plus AC, whereas area is equal to half base into height, that is half BC into AD, and if I take BC as B and the height as H, it is half into B into H, that is the area of a triangle. That is the general form of area, general formula for the finding the area of a triangle. Once we know the base and the height, we can find out the area of the triangle. Now equilateral triangle. Now equilateral triangle means a triangle in which all the 3 sides are equal. That means AB is equal to BC is equal to AC, and the perimeter is equal to AB plus BC plus AC, and that is A plus A plus A, that is 3A, and that is the perimeter. Now to find out the area of equilateral triangle, the area is root 3 into A square by 4, and please remember this formula, and if you want to derive this formula, we can learn it in your higher classes or later when I handle the derivation of this formula. Please remember that. Now coming to the right triangle, in a right triangle we have got angle C as 90 degrees, AB is the hypotenuse, BC and AC are the sides. To find the perimeter, add the sides, that is A plus B plus C, and to find the area, again use the formula half base into height. Half base is BC, that is A, and height is AC, that is B, therefore it is half A into B. Now the scalene triangle. Now in a scalene triangle all the 3 sides are unequal. The sides are unequal, that is BC is equal to A, AC is equal to B and AB is equal to C. To find the perimeter, add the sides, that is A plus B plus C is the perimeter. But to find the area of a scalene triangle, we have to use a formula known as Heron's formula, that is area is equal to square root of S minus S minus B into S minus C, where S is semi-perimeter, or A plus B plus C divided by 2, and that is for the scalene triangle to find the area. Now coming to the quadrilateral. Now if you look at the quadrilateral here, ABCD is a quadrilateral. Now if I join AC, if I draw the diagonal AC, then if BM is the perpendicular to AC and DN is perpendicular to AC, then we have 2 triangles here. One triangle is ABC, other triangle is ADC. So if I add the areas of these 2 triangles, that will give me the area of the quadrilateral. Now first, how to find the perimeter? AB plus BC plus CD plus DA, that all the 4 sides when added we get the perimeter. Now, but to find the area, we have to add add the area of this triangle ADC and ABC, that is half into base, that is AC, into BM, half into AC into what you call DN. Now if I take AC as D, that is AC as D, then it becomes half D into H1, half D into H2. Now what is common here? Half D is common. Take half D outside, H1 plus H2. Again a very important formula to find the area of a quadrilateral. It is half D H1 plus H2, and remember that. Now the parallelogram, we know what is a parallelogram, we know the properties of parallelogram. Now to find the perimeter of a parallelogram, just add the sides of the parallelogram. In a parallelogram, opposite sides are equal. If AB is taken as B, then DC is also B. If BC is taken as A, then AD is also A, and therefore the perimeter is 2 times A plus B. Now the area of a parallelogram is that is base into height, that is AB into DN, or DN is H, the AB is B, therefore B into H. The area of a parallelogram is the product of the base of the parallelogram and its height.